Hello again. I just finished up my demonstration of the distance penalty feature, and while I've got things open here, I think I'm going to show you what happens when we implement the custom constraint and the custom cost to our optimization. So let's go ahead and enable this. Now, with the custom constraint, let's just basically anytime you want to establish a relationship between some of your inputs that you want to stay consistent, this is probably the easiest way to do that. So, for example, what if I had these 15 inputs and I wanted them all to move together in groups of 5? I could do something like this. Let's compile it. Worked okay. Let's test it out. So we should see 3 groups of 5. Cool. Let's save, refresh, and see how that affects our optimized inputs. So now we should see basically 3 lines, and that's what we've got. Let's move it around a little bit and see where we go. Let's go 9.8. See what the combination of this custom constraint with our distance penalty does. So as you can see, we have minimal movement. Okay, so that's working nicely. As another example, we could say, let's say for some reason that I want the second input never to be greater than the first input. So we'll say column 2 equals math.min, and this is basically Java code here that we're writing. Math.min of column 1 and column 2. So this way column 2 will never be greater than column 1. Let's try compiling it. And column 2 is less than column 1 right now in our test input, so let's change this to 0.2. Test it out, and you see we got 0.2 for both. If we're at 0.6, we see column 2 reverts to its original value. Okay, so that looks like it's working. And let's try something with our custom cost. So I have something set up here already. And what this is basically looking at is it's looking at the total actuation of the first 5 inputs, the total actuation of the last 5 inputs, and it's basically saying if the first 5 inputs are not almost wide open, we're going to implement a penalty. If the last 5 inputs are not almost all the way closed, we'll implement a penalty. So the first 5 inputs should be basically close to maxed out, and I could even increase these values to make it more stringent. And the last 5 values should be almost all the way shut, because in a total of all 5 of them, we can't have more actuation than 0.5. So let's compile it and see what we got. Okay. So I'm going to take out this custom constraint so we can just study this custom cost. Do a save, refresh. And let's see what happens. So in order to help visualize the effect of this custom constraint, because just looking at this plot I would have to figure out which color is which, and that's a little tedious. So what I'm going to do is I'm going to calculate that actuation for the first 5 and the last 5 inputs, and I'm going to put it in its own display. So let's show you how we'll do that. So this is going to be calc first 5. It's going to be optimizer 1 dot call 1 plus, I can copy this, make it a little quicker. That's the first 5. And I can just add a 1 to all of these for the last 5. And let's put this into our plot. Okay, so let's save, refresh. Okay, so I can see these in my program here. Our value is 4.5 and 0.5, so we're basically hitting those on the head. And we've also achieved our target criteria of 9.2. So the optimizer is basically doing a perfect job of so it's doing several things now. It's keeping our input values as close as possible to the originals. It's making sure that we have lots of actuation on the first 5 inputs and very little actuation on the last 5 inputs. And it's achieving our target criteria. Let's try moving this to 9. So this time we got a bigger spike than we would expect for moving that little in our target value, but that's probably because these constraints are forcing us to do some interesting things with the inputs. Let's try moving it to 5. Let's see if we can cause these to break, or let's see what fails first. Meeting our target criteria or meeting our custom cost. So it looks like we missed our target a little bit. And that might be as low as we can go while still meeting our custom cost constraints. Let's see what happens when we make it 4. Yep. So that's basically as low as it can go with the custom cost that we've set up. We could relax the custom cost by doing something like multiplying our penalty by 1/10 or 100th. Let's try that. Essentially, we're reducing the weighting factor of our custom cost. So now we achieved our target, and we achieved it by incurring the minimal amount of penalty from our custom cost. We basically just moved our bottom actuation from total activation from 0.5 up to around 1. So this is the kind of process that you're going to go through when you set up the Griffin optimizer. You're going to have to test different values and see what kind of behavior you get, usually while the system is running. Fortunately, we have the tools built in to make that as easy and painless as possible. So thanks for sticking with me through another Griffin video, and I'll see you next time.